This is what I want you to do. All right? Can you make it happen? Okay. Now then, what we got, me getting up here where I'm supposed to be, 2.7 liter engines. To minimize the flexing on these engines, on these 2.7 liter engine, they've been out for a few years. All of them have a structural collar that's bolted to the oil pan and the transmission. And that, to avoid damaging it or the oil pan during the collar installation, you got to use the tightening sequence detailed in the service manual. So watch out for your tightening sequence. A lot of these engines have got tightening and loosening sequences. On some engines, some V engines, if you've got a big wide V6 engine, it's a Japanese-made engine or something, you need to look in there before you just start jerking bolts out to take the manifold off. Because you can conceivably pull all the bolts out, they're holding the manifold on, and the manifold will warp and it won't come off of there. That has happened, okay? So pay attention. If it tells you to loosen those bolts in the order, in a particular order, you make sure you loosen them in a particular. It seems strange, but do that. I'm talking about intake manifolds. But a structural oil pan and windage tray, they're going to be increasing the stiffness on all of the engines. So the edge-molded rubber gaskets for the oil pan, other engine components have got a metal backbone. Why do they put a metal backbone in a gasket? Why do they make a gasket with a metal backbone?
Reinforce it?
Make it sure that it doesn't squeeze too much. If you tighten it too much, it squishes out, and then you got a bad oil leak. Right now, Willie, did you notice that gasket on that transmission on that Pontiac this morning? It had a sort of a metal backbone, didn't it? All right, and it controls gasket compression, is what it does. And there's less of a gap between components, and the fasteners maintain their torque better. See, as the gasket gets littler, it starts to get weak and thinner, then it winds up getting loose, and you wind up with oil leaks. I mean, some of these Crown Vickies, what you'll see, they got a gasket that's aluminum and it'll have silicone on it and stuff like that. Chevy uses that for intake gaskets on some of their, fairly later model trucks, and they have a tendency sometimes to just give away and leak, especially if it's plastic and silicone. It's got a silicone ridge around it. The new gaskets minimize the need for sealant at mating services. Of course, I don't like using gasket sealant anyway. Unless I have to put a little something there to hold it in place, I don't like putting lots of Gorilla Snot on something or nothing like that. On the 2.7, though, you need to use Mopar silicone rubber adhesive sealant at two spots where the oil pan gasket and timing cover gasket meet. And, the other ones, on the 3.2 and the 3.5, you need to apply sealant where the oil pan meets the block and the oil pump housing in the front, okay? All right, now, keep your eye on your questions down there. You got it, guys? All the engines support the crankshaft with 4 main bearings. Now, what does that mean? There's 4 main bearings that the crankshaft spins in. You got me? All right, 6 bolts for each main bearing cap. Wow, that's something, isn't it? The main bearings are numbered from the front to the back of the engine. I got one of these engines you can tear down if you want to over there. The old overhead cam one. All engines use thrust washers, and they're installed in the block after the crankshaft installation. What's a thrust washer for? Thrust washer instead of a thrust bearing. What's the difference, guys? You ever seen, on the one that you guys are working on, you and Daniel, there's a, I mentioned this to one of y'all the other day. It's got the thrust bearing on that one is right at the end. Sometimes it'll be back at the back of the motor, and on a lot of engines it'll be up in the middle. On some strange engines, you'll actually see that the upper thrust bearing has got flanges on it, instead of having just a bearing that's like an insert. It'll actually have a bearing, it'll have skirts on it. You seen those? You know what I'm talking about? That's actually a thrust bearing. What's it there for? Anybody. What's it there for? The thrust bearing, what's the purpose of it? So the crankshaft is trying to move back and forth, right? So what's trying to move my crankshaft? Why is my crankshaft even trying to move that I need thrust bearing? Anybody know? What about when you mash the clutch, buddy? What are you pushing on?
Yeah.
You mash the clutch, you're pushing on the crankshaft. What about when you apply the throttle on a car with an automatic transmission? The torque converter is bolted to the flywheel bolted to the crankshaft. The torque converter swells up a little bit and it pushes on the crankshaft. Pay particular attention to that. Now, on this particular one, instead of having thrust bearings made together, they've got a regular bearing, and then right there next to it, in these little places, they got little washers. Sort of little half-moon washers that go in there, and they use those instead of actual thrust bearings. It's got the thrust built onto it. So there's a machine place on the crankshaft, and there's also a place that's kind of machined in on the block and usually on the main bearing cap for that to go. So the thrust washers there, they're installed on the number 3 main bearing, And on the 3.2 and 3.5 engine, they're located at the number 2 main bearing. So remember that. They're in a different place on those other engines. To determine which main bearing inserts are used on a particular main bearing journal, you need to become familiar with the main bearing select fit procedure. How many of you knew there was such a thing? How many of you know that the cam bearings on some engines are not all the same size? You know those little rings that go in there, that the little ring-shaped bearings that go in there, look like little serviette rings for a napkin or something. They go in there on that around the camshaft. And like on this one Jeep Cherokee that we were doing in here, and there's a lot of them like that. They come color-coded, and you better not put those bearings in the wrong place. They're actually numbered. But Perfect Circle numbers them sequentially. Pick up your head. This is not a place where you can lay your head down, Zach. You overslept today anyway. All right, so now then, what's this? It's got to use one set of numbers on the lower edge of the block near the oil pan mating surface. In early production engines, you're going to notice 6 letters on the block. The letters were used to indicate piston size, and they'd be removed they were removed later. There's only one size piston and connected rod assembly is used for each engine. The numbers on the block are used with the numbers on the letters on the rearmost crank shaft counterweight. On the counterweight is that big, part that's opposite the journal. The counterweight, the numbers ranging from 1 to 3 are used on the 2.7 liter engine, while the 3, 2, and 3.5 use the letters A, B, and C. So they use 1, 2, and 3 on 2.7s, and on 3, 2, and 3.5s they use A, B, and C, which is interesting. Compare them to those in a chart in the service manual, and that'll be in there. It enables you to determine which of the 5 main bearing sizes is used on a particular main bearing. So you don't have the same size for everything, right? That's interesting, isn't it? The way that they make them different sizes and all that, and you got to know what size they are. If the number on the number 1 bearing is 2 on the block and 2 on the crankshaft counterweight, the main bearing grade is the standard size. And that's represented by number 3 in the service manual. Is this confusing?
So,
Yes.
number 2 is standard.
Huh? Yeah, number 2 would be standard. The main bearing grade is the standard size, okay? The main bearing grade is also marked on the new bearing inserts to facilitate replacement. So, and basically, I want to show you that. Let me bust that off there. Fire up that media projector so I can show you what I'm looking at here. If I can get it to come on. Oh, I'm pushing the wrong button. Okay. All right. Another similarity is the oil pump's driven by the front end of the crankshaft. Now, have you guys worked on an engine that the oil pump was driven by the crankshaft? Guys, have you? What?
The oil pump was running with the crankshaft?
Have any of you guys worked on an engine where the oil pump is driven by the nose of the crankshaft?
Yes.
Which?
Now, let me make sure I got this right. My little 92 or 93, I don't remember which one it is, Nissan, the 4-cylinder, he's got dual overhead. And the distributor runs through one side, and then it connects to the end of the.
That's actually driven by the camshaft. What I'm talking about is around the nose. It's around the nose of the. That's what. Look at this, Daniel. You and Garrett are working on that Crown Vicky engine. It's got an oil pump on the front end of the crank, hasn't it? All right, you see them numbers right there? Main bearing grade numbers on the block and a crankshaft counterweight. See that? Look. See where that is up there? 2223, 2232. See? Yeah, that's what you got to kind of pay attention to that. Right? All right, and then make sure you can't just take the bearings out of the box and slam them in there. You got to make sure that you know which ones go where. Now, why they built it that way, just like you've got to specially fit it. Do you know how they did bearings back in the 1930s? You remember the old Bonnie and Clyde cars? The Bonnie and Clyde cars would typically be rebuilt every 10,000 miles, and when they would do that, and don't annoy people, Zach. You need to sit up straight and don't lean back on somebody's paper. All right, now what you're going to do here is they would use lead babbitt. And they would actually put that lead babbitt in there, they'd melt it in there, and then they'd shave it out, and they'd keep working with it until it was the right size around the crank. Isn't that crazy? That's before they had bearing inserts. And they'd also do body work that way. When you dented a fender on a car, they'd melt lead babbitt in there, and they'd shave it off. They'd use lead, to do that. When using the rear main oil seal retainer, see that? Is there a question about that in there? Special tool 8225. To make sure that the retainer is aligned properly. Got it? You can use the opposite side of the same tool on 3.2 and 3.5 liter engines. All right. Now then, everybody got that? All right. Look at that. 2.7 liter engine. Everybody read that page. Connecting rod assembly got some features you ought to be aware of. An F above the piston pin boss and an arrow on the top of the piston must be toward the front of the engine during installation. See that? You remember what I was telling you? You said you had your pistons had F on them for front, and then that had a notch. These have got arrows. Now, sometimes those arrows are not that easy to spot, and you have to brush them off real good. You're going to clean your pistons anyway. You know, if somebody's building an engine right, what they'll usually do is they'll bore it 10 over and drop some, brand new set of pistons in there to make sure it's pretty and round. Did you do that?
I went 40 over.
You went 40 over, okay. You can, if you go 60 over, sometimes you'll get into the water jacket and you'll have to put a sleeve in it. Yeah. But anyway, the oil squirt hole on the collecting rod's got to face the major thrust side of the block. Okay. So, how many of you guys have ever known about an engine that would have a little oil jet spraying on the underside of the piston?
I've heard about that.
Yeah, that is basically like Power Stroke diesels have that. It helps to keep the piston cool. So you just basically squirt it. Yeah.
Paper for me or something.
A paper. Oh, yeah. I need to get that. Grab that right quick. Grab that compressor and put it in your truck. The one that's out there, not the one that's not without a box, but the one that's in a box. And I'll grab you that paper. Give me a second. All right. Now, together with the piston orientation markings, you got to know the correct squirt hole orientation. See how this is what I'm getting at here. You've got to. It's not like building a 350 or a 302. These newer engines, it's got these aluminum heads and the overhead cams and all that. What we have a tendency to do, Matt and Garrett, what we have a tendency to do is we have a tendency, sometimes we're in training, if we've got an engine and we're taking it apart and putting it back together, where we just sort of cram things together so that it looks good, and then we shove it off to the side and we try to get our worksheet signed off without even. And how many of you guys have, and you've run into this, where you come along behind where somebody else was running through a little self-driven training exercise, and the engine is locked up and won't turn. They put it together wrong. The engine's locked up. That's what they ran into on that other one. They somebody that says, put that motor together for me and just put it over there and when they got through, they had just crammed it together the best way so that it would look decent, but it was not functional. See what I mean? You cannot do that. Imagine somebody doing that on a car that you were going to drive to Nevada, You have to depend on that thing to go from here to way out yonder without giving it any trouble at all. You know what I mean?
All
right. Now let me ask you this: how many? If you ate 100 hamburgers from Burger King, what would be an acceptable ratio of burgers with a hair on it? 95%, maybe. I mean, 5 burgers with a hair on it, and 95 without a hair. Is that okay?
No, that's not good.
That's not good, is it? You don't want no burger to have a hair on it. Okay, so what I'm getting at is, what percentage of the steps in going through putting one of these engines back together is supposed to be done right? I mean, I did it 95% right. The engine was knocking a week later, but I did most of the job right. You see, it's got to be 100%, and that's what people expect. In this business here, this is a thing. It's a little, you've got to be really take it to the stratosphere, because you can do everything right, torque every bolt right, make sure there's not any oil leaks anywhere, do everything just like you're supposed to. And I've said this before: 1/2 of a greasy thumbprint left on a fender, and you're a dirt bag, and they'll never bring their car back to you again. See what I'm saying? Or grease on the steering wheel, or something like that. Everything has got to be just right. And and people. Every shop I've ever worked at, without fail, some customer always notices that somebody left a greasy handprint. One customer brought his car back and he said there were greasy handprints on the cross member up under there by the transmission. He didn't like that. He said he should have cleaned that up better. These guys are looking. Some of them will lay down on the ground, look under there, see what you did. You know what I'm saying? So that's one of the things. This is a real tight engine as far as the way everything got put together. On the pistons, you got to notice the connecting rod was fractured during manufacture. Who's seen that? Fractured connecting rods. They machine them up there, then they scratch them and pop them off, and then they fit back together like a coffee cup handle that broke off. They're just a perfect fit, right? And y'all found all the right ones that went with the right ones, because some people, they just swapped them around because they didn't give a rip. So y'all took that. Fractured rod, it's important to make sure you mark the cap so you can put it in the original position. Don't mark them by stamping them. Use a marker or a paint to avoid. They're afraid if you whack them, you'll actually, because of the material they're made out of, you might cause them to develop a crack that will happen later. Connecting rod cap bolts are captive fasteners. But since the bolts should only be torqued a limited number of times, they can be removed and replaced. Now, what is a captive fastener? What do you think? To avoid captive fastener means what? Have you ever took a part off and the bolt couldn't be taken out of it? I mean, you got a bolt going through a part that you're taking off, right? You take part off. Well, the bolt won't come out. It's rattling around in there. It rattles around, but it won't. You can't get it out. That's what you call. That's a captive fastener. In other words, the bolt is actually a part of it. When you pull it out, you can't pull the bolt out, lay it on the bench. It stays with the. It's rattling. Yeah, see what I'm saying? Yeah, they're captive. That's what they call captive fasteners. Now that engine there is built very similar to this 2.7 I'm talking about. These overhead cam aluminum head engines, they're set up that way. So they can be removed and replaced. To avoid damage in the cylinder bore, the crankshaft journal, special tool guide studs, 8189. We use a piece of hose, works for that. You put when you put them pistons back together, you put that on there. Gotta love that telephone. Hello? Hey. Yes, ma'am. Right. I'll have to get that from him. He hasn't sent me anything yet, but he will, and he'll have to send us that form too. I can call him today and see if I can get it from him. Okay. Sure, that's fine. Yes, ma'am. Alrighty. All right. So earlier, let's see. Let me look at this. The new tensioner, has got a position. See that there? New belt. Tensioner's got one position used when installing a new belt, and another position when you're installing a belt that's been on it for 500 miles. The new belt has got belt stretch. All right. Let me ask you this: how many of you guys have put a belt on, like a particular parts house belt that you buy over there, and unless it's a spring-loaded tensioner that you're using, if you got one that's got a tensioner, you tighten, like an alternator that you probably over tighten it up, or that doggone thing, that belt will stretch and start squealing. You got to tighten it again. It'll stretch and start squealing. You got to tighten it again. And some of these cheap belts you get from some of your mass marketing parts houses, that's made to sell to people walking in off the street. If it's not a spring-loaded tensioner to automatically tighten it up, you'll have to tighten that belt 5 times sometimes before you get it tight enough to where it won't squeal. And that's a pain, especially if you do it.
I remember you telling me about them. I know something else in middle school, like the Gatorback belts.
The ones, not necessarily the Gatorbacks, the ones they've stopped making them.
Did they?
Yeah, the ones that I'm talking about that I showed you the picture. I mean, I've got a belt over here somewhere like the one I was talking about, and it will make Zach, you had that. Zach, somebody whack you on the top of the head with something. But Zach, you remember that your mom's Jeep was making that noise, and that old Jeep Wrangler, and we changed the belt to fix it. Remember that noise? What kind of noise was it? It was a whining noise. It sounded like a bad bearing or something. And then when I saw the belt, I said, that belt's the problem. And we put another belt on it. That's all we did, and it took care of it. But now, just because it's got ridges in it is not the problem. One company was making belts that was really shiny, and it looked beautiful if you just looked at it. But boy, that was a noisy son of a gun. And I'd have people call me and say, I got this problem. I've changed the power steering pump. I've changed all the bearings. I'm still having this problem. My belt's brand new. I said, what's the belt look like? They'd tell me, I said, put a different belt on it. It'll be fixed. And they change out the belt and take care of it. But you don't see those anymore. They quit making them, basically. And so, I mentioned them in a magazine article, and, they called the magazine, were raising Cain about it, but they quit making those belts that way. Because, the belt was okay, except it made noise. You just can't have a noisy belt. All right, got a number of unique features. There we go. Remove the tensioner to change positions. Now look at that. You got a tensioner that goes in 2 different positions. Who's paying attention to that? Take your main tension on the spring. So you're going to put it in 2 different. Now look at this. See the locking bolt? See that picture right there? Right there. You maintain tension on the AC drive belt tensioner spring when you're removing the locking bolt to prevent the sudden release of spring tension. See how it's got an open spring out there? You see how that looks? Let me see if I can zoom in on that a little bit. See if we can make that happen there. See how that looks? So
that's the tensioner there, right?
That's the tensioner there, and that spring is a naked open spring out there. See? So you need to, I mean, some of them have that. You know, I mean, that's not on every year model, but you need to watch for that. Now, something else you're going to be looking at right here, on the crankshaft damper, on that to serve, you're going to have to remove the crankshaft damper using several special tools. Don't you just love it when they come up with all these special tools? 8191 to hold the damper when you pull in the crank bolt. That's right there's going to, you know, make sure that you're able to hold it still. Right? Yeah, you should have. That's actually dealership stuff right there. Puller 1023 and 8194. We've got a puller that'll work for that. That son of a gun right there, if you look at them Chrysler dampers, they don't have a keyway in them. They're just a really strong interference fit. And you better have a good stout puller that will grab those little ears on that thing good but pull it off of there. And that's something they really enjoyed using. Now, the really early ones on some of the Chrysler products that had them kind of interference fit, you know, without a keyway on them, that son of a gun would have to be drilled. They would not have any way to grab it with anything. You'd have to drill and tap holes in it and use a regular balancer puller. And I don't know. And then the one you replace it with, like when we have to put one back on there that was a new one, it would have the rat, you know, those little things on there. All right, timing cover, edge molded rubber gaskets. Talking about that water pump mounts directly to cylinder block. See where the water pump is on that? Now, what do you see that's distinctive about that water pump? What drives it? The timing chain, guys. If you have to replace a timing chain on one of these engines, and you're going to have to pull it, I mean, you got to put a water pump on it, you got to pull the timing chain out. And you know what you have to do to pull the timing chain out on one of these? If it's a sideways 2.7, you got to pull the motor out of the car. Ain't that nasty? They've also got a little weep hole right by the thermostat. The thermostat on this engine is the side of the engine block behind the air conditioner compressor. They don't have it in that top hose. They got it on the side of the engine block. And what you got to do there is you got to take that air conditioner compressor off if you want to do it right. The side of that block's aluminum. And what happens if you're not really careful and you're trying to work at an angle, with that you'll strip one of them bolt holes. There's 3 bolts that hold that thermostat on there. If you strip one of them, you know, we're talking the side of the block, man. Now what are you going to do? So this one guy that I had here one time was working on one of these, and he decided he was going to, you know, the threads were messed up, and he was going to run a tap in there and put a heater coil in it.
Can't do that.
Well, you actually can. There's not any reason why you can't do that. But he was trying to work around the air conditioner compressor instead of taking the compressor off, because it wasn't that hard to take it off. He just trying to work around it. And he broke the tap off in the hole. Brilliant. This was a 2004 model car. You know, what we're going to do? This is, you know how much a car's worth? I mean, even this was several years ago. All right, but let me do this. Watch this now. This is important. This is the stuff that you don't learn at, you know, some of your big, you know, colleges. I've got a hole here, and I have actually broken a tap off in there, and that's what it looks like. Now this is an aluminum block. The taps broke off in there. You know, I mean, this is a dicey situation, guys. You know, you're that close to trashing the engine. Because if you can't put the thermostat housing back on there, you ain't got no sealed up water jacket. You can't drive the car like that. I mean, what you gonna do? Weld the thermostat housing on there? I don't think so. You know where I'm going? I mean, it's popped off in there. So how you gonna get that out of there?
Can you punch it out? Real carefully.
Well, then you got to deal with some threads.
It's
You know,
screwed in, right?
huh?
It's screwed
Yeah,
in.
it was screwed in there,
Could you use
and
like
then
needle
pop.
pliers and put it in between?
Well, you could try that, but it's little. It's just 6 millimeter, man. It's teeny.
Oh.
It's a little bitty thing. That's why he was able to break it.
So you got to back it up out of there some kind of.
You sure do. Here's what I did.
You can build it a tool.
Here's what I did. I drilled 4 holes. Just let the little existing flutes guide me, and I drilled 4 holes. Got it? So I didn't have anything here anymore. And then I was able to grab that tap and turn it a quarter of a turn where these high spots were in those holes. Just pulled it out of there. Got me? Well, see, he was actually running a 6 millimeter tap in there. Then we ran the helicoil tap in there, which is a size bigger. And then we put a helicoil in there, and then we were able to put it all back together. But to get that broken tap out of there was what was so dicey. You know, without making that hole so big that you could put nothing in there. You know, but you gonna get a toggle bolt like you buy at the hardware store and put in there? I don't think so. You know, anyway, that was a booger bear. I mean, that was a spooky situation right there. And that's why you got to be really, really careful and all that. One of the things that I have problems with in here is people will get something past the point of no return to where it's completely rounded off and ruined, and then they want me to come work a miracle. And they did it usually with an impact wrench. Just maybe if we just keep letting it keep spin on there, we'll get it on off. But it's nice and round. I mean, it's just as round as anything you ever seen. And he said, I can get this out. You'll be a miracle worker. All right, now passages in the block allow the water pump to vent. One we pull near the thermostat housing. That's what I was talking about. If that one stops up, listen to this. If that one stops up, it'll fill up the valley underneath the intake and run out around the transmission, which is on the opposite end of the engine. Now, there's another thing that can make you think you got a water pump leaking when you don't. That plastic housing that the upper radiator hose goes to that's got a little bleed screw on it, if that thing starts leaking, and sometimes they do, it'll fill that thing up and you'll think you got a leaking water pump. Now, if you look under there by the thermostat housing and that little weep hole that's supposed to let the water pump leak, why do they have it venting out that way? They don't want it leaking. They don't want to put the weep hole where it fills the engine up with water. So they're going to go out. It's got one weep hole going out under the manifold, and it's got another weep hole going out by the thermostat. The one by the thermostat usually gets stopped up by dirt daubers or whatever. I don't know. It's all usually clogged up with crud, and so it's got to go somewhere. All right. The other passage goes up that way. So, and there's your little bit of see. Look at the thermostat weep hole. See it? Everybody look at that. Don't miss it. There's a picture of it right there. All right. Let me move that over. If I can find my mouse pointer right there. See that weep hole right by the thermostat housing behind the air conditioner compressor. That's what you got.
That's the coolant lever?
That's actually no. That's so if the water pump leaks, instead of having a weep hole right there on the water pump, which is behind that timing cover in the oil area, they don't want that. So they're gonna let it drip out right there. And that little dark hole right there next to the thermostat housing, which is behind the AC compressor, that son of a gun will clog up with dirt, and then the water goes out another weep hole that's in the valley. That's what I was talking about earlier. All right. Now this one right here is just a single overhead cam, but you might notice on that one there, there basically is what you're looking at. See, they use chains to turn the intake and exhaust cams and the water pump. And why would anybody put that water pump? Who else? When did GM ever do that? You remember? How many of you guys have worked on 2.4? The quad 4. That's got that's got no plug wires. It's just a old 4-cylinder quad 4, like they were using them, in the 90s and early 2000s on Oldsmobile Aleros and cars like that. You open it up and it's just the top of the engine just curved and it says quad 4 on it, and it's got some little coil packs built in there. But you don't see no plug wires, you see no distributor, you don't see nothing. It's just a real clean looking engine. But the water pump is pulled by a chain on that one too, and you got to pull that end off that thing, put it in it. I mean, this is serious stuff. You may as well replace the tensioner too. There's a wear indication groove right there. In the chain drive system, you got to wear the plunger extends further out of the housing, and you can see the groove. See that thing right there? That's really important too. Rotate the crankshaft to provide the tensioner side of the chain with slack. That lets the tensioner fully extend because it's spring loaded sort of, but it's also got oil pressure pushing it. We're going to look at primary timing chain removal here. All right, now look at your marks. See your marks? Let's zoom in on that a little bit. All right, we're going to go over. Let's zoom back out. See how that looks? You got crankshaft timing mark, crankshaft sprocket, and then you got intake timing marks. You understand what you're looking at there? Now look at that. We got two teeth right over there lined up with that mark. We got one tooth lined up with that mark over there. And I'll even wheel the camera around so that you can see it up that way. See that?
So it's just three marks.
Pretty much. Oh, you got the color links on the chain and all that kind of stuff. See?
I mean, so you got to be concerned about this one, and this one down there.
Yeah, down there on the bottom, you got that little mark right down there, and then you got the little mark. These it's up here at the top. And you got that on that one there, on this particular one. And there's your chain tensioner. See what I'm saying right there? Got the tensioner arm, chain guide. Now you guys got a sheet on this too, And I got one of these that's dual overhead cam over there, which is a little more complicated than this, but it's basically one that's got a setup kind of similar to this on it. All right, I'm gonna turn that around there.
Now that we're talking about
zoom back up, huh?
And now we're talking about the timing chain.
Yeah. I just noticed as I'm looking at this camera that I need to put a little bit of thread on one of my ASC patches trying to come off. All right, now then I'm going to back it out of this.
Sorry, now that we're on the wear of the tensioners and stuff like that.
Huh?
Now that we're on the wear of the timing chain tensioner.
What about it?
Says Technician A says that on 2.7 liter engine, the groove on the primary chain tensioner disappears when the chain is warm. Technician B says that as wear occurs, the tensioner extends and the groove becomes visible.
There you go. Who's right about that? B, isn't he? That's right. All right, now let's whip through the rest of these questions right quick. We're going to see. Which ones have you already got the answers to for?
1, 2, and 3.
Okay, on the 2.7, you need to apply sealant. That's going to be A. On a 3.2 liter engine, the main bearing number on the block is 3. The letter on the crankshaft is C. What's the bearing grade? Standard. Very good. So Technician A says on 2.7 liter engine, the groove in the primary chain tensioner disappears when the chain. That's B. B says that it actually you see the groove. 3. There's a difference between the blank on early and late build engines, and that one there is going to be the 2.0 liter secondary chain tensioners are different. Just remember that. We're needing to hurry a little bit here. At top dead center of the exhaust stroke, the intake's cam secondary chain sprocket timing marks should be how many degrees from the cylinder head, cover sealant surfaces, and blank pins from the marks on the exhaust cam sprockets. That's rough, isn't it? That's a rough question. Who's going to memorize that? That's 90 degrees from the cylinder head, cover sealant surface, and 12 pins from the marks on the exhaust cam sprockets. Now you can see this if you look this up in your shop manual. You're going to run into these pictures, right? There, you got to know how to do this stuff, though. Well, I was telling Daniel a while ago. I says when you go to a place, you can go to a shop and you can go to work out there, and you can go around 2 days. They can tell if you know what you're doing or not. To arm the primary chain tensioner on that one there, we'll just jump straight to that. You got to pry the tensioner arm toward the tensioner. You're going to pry it toward it, you know. And when you arm it, that means you basically load it. Number 7, which of the following statements about the 2.7 liter engine rocker arms and lash adjusters is true? We didn't talk about that earlier, but basically, all of them. Remove the rocker arms using special tools, 8215, 8216. You don't have to have those. You can get them out of there. You can replace the lash adjusters separately. Those are actually the little lifters that we would call them. Store lash adjusters in an upright position. You remember when you see me pulling little lifters out of the block? Out of the head there? Sometimes those things will collapse and they'll start going clickety, 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 click. And if you can figure out which one it is, you can change them out real quick and real easy. The lifters, what you got to do to change the lifters out on one of our old V8 engines? You got to pull a manifold, don't you? You got to pull a rocker arm, manifold, all that hogwash. It's a pain. On these right here, you pull a valve cover. If you can find the one that's making the rackets, you can pull that. You pop that rocker arm out of there, pull it out, drop another one in, put that together, to smooth itself. Yeah, yours is a disaster waiting to happen. Okay, Technician A says the 3.2 liter engine camshaft uses 3 lobes per cylinder. Technician B says the 2.7 cams are interchangeable. Who is right about that? A, believe it or not. Yep, 3 lobes per cylinder. Which of the following is found with a 3.2 and 3.5 engines but not with a 2.7 engine? Number 9, B, engine oil cooler. And finally, number 10, coolant bleed valve on the 2.7 liter engine is located where? The coolant lead valve now, not the weep hole, the bleed valve. On that one, it's located on the water outlet connector. That's up there right in front of the manifold. We're actually on the end closest to the belt. You got that? All right, we got a few minutes to jump through this other one here. And we'll be talking about some other stuff there. If we can get our paper peeled away here. Okay. Let's talk about MLS gaskets. Okay, and we're going to plow through this, and we're going to hit highlights while we're going. MLS. What do you think? Can anybody tell me that? What's an MLS gasket? Somebody tell me what an MLS gasket is.
Multiple loop solution.
Major leaking.
Yeah, that's pretty good. A multiple layer is what the ML stands for. Who else knows? I get really tired of this phone. Hello. Hey. Hey, Lynn. Okay, now then, MLS gasket. Well, basically, let's look at that. They use what? Thin rubber coating between layers. Basically, you got a rubber, it's like layers of head gasket. The old head gaskets we were used to were different from that. The most of it. Well, let me ask you this: Have you seen a gasket like this? Any of you guys?
Rubber gasket?
No, this is head gaskets. Now, what about your Crown Vic?
Yeah, this one when we rebuilt the Crown Vic engine.
Huh? Yeah, the one you pull off Crown Vic engines is that kind of gasket. It's got basically, if you pull up, it's got a bunch of different layers. It'll have steel and it'll have rubber and it'll have steel, and you're going to do that. To avoid air pockets in the coolant system when performing a coolant fill procedure, and if you were talking about a 2.7, what would you do? You're going to use a special funnel and a bleed screw. Now, the biggest problem with the bleed screw on a 2.7 liter Chrysler engine is the stupid bleed screw usually seizes up on those suckers, and you can't get it to break loose. That's terrible. But that housing that comes with the coolant sensor in it and all can be bought from the parts house. They usually got them in stock. They cost about $50. But if you have to have one, you got one there. There's also a hose you can pull right there by the bleeder, and you can bleed that, but it's best to use a bleeder if you can. Both of these are Chrysler things. On a 2.7 liter V6 engine, there's a 7,000th inch warpage on the cylinder head and 10,000th inch warpage on the block. Wow. Number 3. This amount, is outside combined machining limit for the head and the block. You could have figured that out because that is a lot of warpage. 7,000ths and 10,000ths. Bad news. What that means is you throw that motor away, put another one in it. TSB 9-05-98 specifies replacing what as a part of the cylinder head gasket replacement procedure. Number 4, the cam sensor seal. I'm going to put one of those in there. I tell you what, guys, when you've got a seal that you can get to, it's a good idea to put one in there. You know what I mean? Because a lot of times you'll wind up. What seal do we usually replace on the transmission when we pull the engine out of one? On the transmission. The torque converter seal. You pull the transmission, you pull the engine out, the torque converter's just hanging there, and it'll distort that old seal, put it back in, you got a big transmission leak now. That's aggravating, that you didn't have before. So always replace that torque converter seal if you got the motor. If you
That's what I wanted to tell you about that Grand Am. You remember that thing you did when you raised the engine up and then all of a sudden when you let up all did that, you said that the torque converter wasn't it was like something was wrong with the torque converter.
I don't remember that. That was
in the Grand Am. We was driving something else, but you drove it down the road and you said, now we're gonna watch this. And the RPM went up and it like hesitated or stalled or something like that almost.
Yeah, the torque converter was if it was a modulated slip and it grabbed, sometimes it'll do that. But I don't remember that set of circumstances. But I do remember showing you that, but I don't remember what the details were.
That car did it this morning. I can't describe it like it was, but it did what you tried to show me that day.
Yeah. There's if those torque converters, used to, they just locked up solid, and then they started slipping them, and if they what you're at, basically the way you're supposed to, if you're driving it real smooth and the torque converter locks up, it'll drop some RPMs real gentle. It'll go from up high down to below usually 2,000 RPM driving down the road. I guess that's what you're talking about, but I don't know. Like I say, there's so much stuff that goes on around here. Okay, on examining an engine, you notice oil in the cylinder head seal area. What should you do? Huh? Come on, guys. What do you do? What about attempt to pinpoint the leak? Yeah. How are you going to do that?
Use dye?
That's a good idea. You can use dye. You can actually clean it off and see where it gets wet. You can spray some Dr. Scholl's foot powder on it, which paints everything white, and that oil is going to come out dark. You can see where it's leaking in, That works pretty good. Which of the following statements is true about cylinder head fasteners? A, they're torqued in a numbered sequence. B, they're all the same length on a particular cylinder head. C, they're generally tightened from the outside inward. D, they're all tightened using the torque angle method. That's going to be A, They're torqued in a numbered sequence. But that is not only that, you've actually got torque angle stuff going on with the ones. Which cylinder heads are held on by torque to yield bolts? Torque to yield being the ones that you go to a certain foot poundage and then you go 90 degrees and another 90 degrees or something like that. You ever seen those? If it's got aluminum cylinder heads, you'll have torque to yield bolts on it, basically. Now, why in the world, what's the problem with having an aluminum cylinder head and a cast iron block? You ever think about the fact that, yeah, they expand and contract at different rates. And anything, if you've got any cast iron bolted to an aluminum and they both get really hot, you're going to see them with gaskets that will be coated with graphite usually, like EGR valve gaskets, because if you don't, they'll just continue to scrub until there ain't no gasket there, and then you have a big leak. So they put graphite on there so it can expand and contract while it's sliding, see? I mean, a lot of times we don't think about that kind of stuff, but that's the way they have to do stuff. I mean, there's more to a gasket than something stamped out of a piece of paper, you know what I'm saying? So white 3M Roloc bristle discs should be used where? At close to the maximum recommended rotation speed. Okay, now this little, angle, I mean, this little 90-degree thing that we got in the toolbox out there, you know, when you pull the trigger on it, your air's hooked to it, how fast does it spin? Anybody know? What's the speed of that little, it's a little 90-degree air tool, and all it's made for, you put a disc on it and you spin it, and also that one over there in the tire machine that we use to buff with, which really it spins too fast. 20,000. That's how fast that thing spins. If you just pull the trigger and let it scream, that thing's spinning 20,000 RPM. Now, let me hit you with this. If you've got a bristle disc in there, it's liable to throw little bristles off of that thing in a big way when you're spinning it that fast, right? You spin it too fast with a tool. So then you got little bristles that are like little bullets coming off of there. And that's pretty damaging, isn't it? That ain't good. Anyway, but the maximum recommended rotation speed, you're going to get that from, whoever built the disc. And I don't remember what it is, so don't ask me. Technician A says, a faulty thermostat could be the underlying cause of cylinder head seal leak. Technician B says a lean fuel mixture could be the cause. Actually, both of those guys could be right. Why? Why? I want you guys to be critical thinkers.
A faulty thermostat? Causes more pressure.
Yeah, get too hot, wouldn't it? It gets too hot, pressure bills, it can warp things and all that. But what about the other thing? What about a lean fuel mixture? What in the Sam Mills I got to do with anything?
Make it burn hot.
It's going to be hot if it's lean. Even in the exhaust system, a lean exhaust is hot and a rich exhaust is cool. You got me? All right, specifications found for cylinder head flatness can be found where? Is it stamped on the head? Is it on the engine data plate? Is it in the appendices of the diagnostic manuals? Or is it in Group 9 of the service manuals?
In Group 9.
It's in Group 9. That's exactly where it is. Which of the following should not be used to tighten a cylinder head bolt 90 degrees? T-handle, ratchet, breaker bar, or torque wrench?
Breaker bar.
Now, the 90 degrees, that's a torque to yield thing. You know what I mean? So you're going to have bolts that are made to stretch. When you're torque to yielding, first time I ran into that was at the Lincoln Mercury place over there. And I was used to just, when I was working, man, I was humping it. I'd go over it, I'd get me up had his head off his Escort, popped it back on there, went to where the literature was, flipped open, saw 44 foot-pounds. I said, well, that ain't much for a cylinder head, but that's what the book said. Click, 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 click. That was in 1984, I think. All right, so I realized after that darn thing left, I went back and looked at the book for something else. I stumbled across that, and I was supposed to have gone farther. In other words, I was supposed to go 90 degrees and another 90 degrees on every head bolt, but I stopped at 44 foot-pounds. And I kept expecting that car to come back with a blown head gasket, and it never did. I don't know how I got away with that. I mean, because really, you're wanting the thing to stretch them bolts like a spring, you know what I'm saying? So it always holding really, really, really tight, because as it expands and contracts, it's like he was talking about, so it's going to pull on that thing. So what are you going to do this with? You going to use a T-handle? Huh?
Well, I don't even know what a T-handle is.
It's a little T-handle thing is
Should
gonna.
not be used.
Yeah, it looks like some of you turn aside. It's like imagine an extension with a little T-handle on top of it,
Oh, okay.
made like that. What about a ratchet? Huh?
No.
Well, I mean, can you turn a head bolt 90 degrees with a ratchet? I guess if you have big long ratchets, you could. What about a breaker bar, torque wrench? Did you use a torque wrench for that? I don't think so. I'm not going to use a torque wrench for that. Huh? Pull that thing down.
So we gonna go with torque wrench?
We're going to go with a breaker bar.
Oh, so
We ain't going to do it with a
was
torque
brake
wrench.
bar.
Yeah, we ain't going to do it with a torque wrench. You know, but you can, I mean, you can always.
He's like, I wouldn't use it. Oh, wait, the next breath.
Don't use a torque wrench on those things. I mean, but what you're going to need to make sure that you know, though, is you're going to need to pay attention to all the details. If you're putting an engine together, or you're putting a cylinder head back on, or something like that, and you do something a little bit sloppy just to get past the job. And what have I said so many times? Anytime, and you said this works whether you're working on a trainer car or anything else. Anytime you get tired of working on something to where you're sick of it and you just want to be done with it, you're going to screw it up.
Yeah.
Every single time. You have to hold a high standard all the way through. And how many times have you ever know that some of these people, if you're running a whole bunch of cars through there, it's another car and another car and another car and another car, and I'm going to get through this and I'm going to go home and eat my cornbread, because I'm tired of this mess, all that kind of stuff. And you miss something critical on the last car, you see, that causes somebody to get broke down. Well, that's important to them. It may not be a problem for you right now, maybe later, but if you don't do it, if you don't do a good job. Now, another thing you need to make sure is that you learn everything that you can learn while you're here, because the stuff that you don't learn while you're here is going to cost you when you get out there. You know what I mean? I mean, it's not about getting through I want to get past this, I want to get these things on, I want to get it as little as I can get done and still get by and maybe get a passing grade. Well, you're going to wish that you had done all the worksheets and then some when you get out there and they start throwing work at you. And you're thinking, wait a minute, we had a worksheet on this, but I didn't learn that. And so I don't know how to do what he's given me to do. And now I'm embarrassed. And now I got to go to him. So I'm going to mess this up because he gave us an opportunity to do this, but I chose not to do it because I was lazy that day, or I didn't feel good, or I came in late, or I didn't come in, or I showed up with clothes that were too nice to mess up. You know what I'm saying? I had one person yesterday when I told him to do a particular job. He says, "This is my nice clothes. I don't want to mess these
I
up."
know exactly what you're talking about. He told me the same thing.
I think we overwhelmed her with what we just took. She said, give her a few days.